Greetings! Welcome to Pablo Hidalgo's tutorials and lesson number 5 of the CCNA Complete series. Today, I will present to you data link layer using Ethernet. The data link layer, or layer 2 of our 5 layers hybrid module, prepares network data for the physical network. The data link layer is responsible for network interface card, or NIC, to NIC communications. The data link accepts data from the network layer, usually layer 3 PDUs such as IPv4 or IPv6 packets, and encapsulates them into layer 2 frames. Then, it delivers these frames to the physical layer in order to be transmitted over the network media. The main function of the layer 2 is to exchange frames between endpoints over the network media. Also, it performs error detection and rejects damaged frames. The IETF does not define the functions and operation of the TCP/IP lower layers, such as the network access layer. There are other engineering organizations that define open standards and protocols that apply to the network access layer, that is, the physical and data link layers. Between those organizations, we have the following: International Telecommunication Union, American National Standards Institute, International Organization for Standardization, and the Institute of Electrical and Electronics Engineers, best known as IEEE. The factors that differentiate one type of network from another are difficult and sometimes confusing. We will use a few criteria such as size, geographical coverage, and ownership to make this distinction. A local area network, or LAN, is usually privately owned and connects the hosts in a single office, building, or campus. A WAN has a wider geographical span, spanning a town, state, a country, or even the world. WANs are normally created and run by communication companies and leased by the organizations to use its services. In 1985, the IEEE started the Project 802 to set standards to enable intercommunications among equipment from a variety of manufacturers. Project 802 does not seek to replace any part of the OSI model or the TCP/IP protocol suite. Instead, it is a way of specifying functions of the physical and the data link layer of major LAN protocols. Ethernet is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. It operates in the data link and the physical layer of our 5-layer hybrid module. Legacy Ethernet uses a bus topology, or hubs, in a shared half-duplex medium. Half-duplex allows only one device to send or receive at a time on the shared medium. Ethernet over a half-duplex medium uses a contention-based access method called Carrier Sense Multiple Access with Collision Detection, or CSMA-CD, to ensure that only one device is transmitting at a time. CSMA-CD allows multiple devices to share the same half-duplex medium and detects collisions, which happens when more than one device attempts to transmit simultaneously. It also provides a backup algorithm for retransmission to be used after a collision is detected. Modern Ethernet LANs today use switches instead of hubs. The switches operate in full duplex mode. With full duplex communication, many devices can simultaneously transmit and receive on the dedicated medium. Full duplex communication with Ethernet switches do not require access control through CSMA-CD. Also, we are not going to have collisions anymore. A MAC address is used to identify the physical source and destination devices on the local network segment. MAC addressing provides a method for device identification at the data link layer of our 5-layer module. An Ethernet MAC address is a 48-bit binary value. To make them easier to handle for us, we use hexadecimal numbers to write MAC addresses. A single hexadecimal digit represents 4 binary bits. Therefore, a 48-bit Ethernet MAC address can be expressed using 12 hexadecimal values. Each manufacturer has its own style for representing MAC addresses. Some use 4 digits separated by column, like the one you are seeing on the screen right now. Others use 4 digits separated by dots, and others uses 2 digits separated with column. Please subscribe to the channel if you're not already a subscriber. For our next lesson, we will continue studying Layer 2 technologies, and I will present Layer 2 switches and the very important Ethernet 802.3 frame format. Thanks for watching. See you in our next video. Goodbye.